Dear colleagues, I would like to begin by expressing my sincere gratitude to the Technical University of Kenya and the colleagues organizing this conference for inviting me to deliver this keynote. It's both an honor and a privilege to contribute to this important conference and to engage with such distinguished academic community. Generative artificial intelligence and the politics of perception, artistic practice as critical intervention. This is a title I chose, and I'll step right in and begin with the first question I'd like to pose, and the question is, what's the problem with generative AI or GAI? In order to understand this, what's the problem, we have to take a closer look at what such kind of AI is and what it does. And so please abide with me for being a bit technical about this, not too much, but let's see. Let's see how such a text-to-image AI works. So it has basically three components. It has something that's called a clip, a contrastive language image pre-training module, and then it has something that's called a unit. We don't care for the technical terms here, and a scheduler, and finally a decoder. And we will look into these components now. So what we have here is a component that translates the words we put in as prompts into images, but not the concrete images that are generated by the AI, but it's just a module that has been trained to connect words and parts of images. Actually, that has built up statistical patterns between billions of items, words and images connected in the data set. So what it does is it projects images and words into what is called a high-dimensional space. That is a vector number with many dimensions that can then be combined. And here's an example of that. It's not from me, but from the website that introduced this open source clip module. And as you can see, there are descriptions of photos, and there are photos, and they are both encoded. And this is already a complicated part where a machine learning algorithm runs over these and extracts more and more complex patterns of these items, and then brings those together in a matrix. So these are the picture of the dog and the word Pepper the Aussie pup in this case are then intertwined by quantitative numbers, so to say, and you can calculate with those numbers. Imagine you would be doing this with billions and billions of data points, this kind of comparison. So you build up a certain knowledge, and you can use this knowledge not only to do text-to-image AI, but also to identify features of images. So if you take this very, very powerful clip technology and feed it any image, it will give you always a result. If it's the a true result or not, that's another question. So let's have a deeper look at this clip module, how it works. So the first thing is it builds up statistical patterns, and then it tells us something about reality. But this is not knowledge. It's actually it's millions of interconnected statistical hypotheses, you could say, because this frame that we saw, this matrix frame, it's just an hypothesis of what the system has learned about statistical patterns of two different items, and then of millions of different items, first thing. Second thing, where does the data set come from that is used to train this kind of clip network? It's scraped off the internet, often proprietary, sometimes open source, so you can register and download this data set if you want so, the open source variant of that. But there are a lot of questions attached to this question of where the data set comes from. First question is, have the creators of the data been asked or even been paid? And this is not the case. Usually these data are just scraped off the internet without asking anyone for permission. And of course, this is a problem of fair culture. Secondly, which regions are represented? Who selected the data that represents the regions? Also, no idea, you could say, because it's just a random sample or anything a bot could find to scrape off the internet. So there's no person behind that who would take care for any kind of representational question. Third question, who cleaned the data sets? In the early days, these data sets contained any image that you could find on the internet, and every one of us knows that this is not a good idea, because there are a lot of images that are attached to problems to various degrees, from extremely violent pictures or extremely pornographic pictures, and to pictures that are problematic representations of groups of people, such as sexist pictures, which actually is a big part of the depictions of women on the internet. So, and all these kind of pictures have to be cleaned nowadays in order to train this kind of network, so that it gives kind of ethical or at least not illegal results. And who does this? We know this is done by click workers who had to manually sort out these pictures for not much money, and who had to bear all these psychological stress that seeing these pictures causes. Also, of course, they have to tag these pictures, so they build up what things mean. And you could also ask, is this a qualified position under paid workers to tell us in the end what things mean? And then there's the question of what happens to things that cannot be quantified at all, as picture or as sound or as whatever. You know that these things that can be quantified are not everything that we live in. I would say most things that qualify our life world cannot be quantified, being it atmosphere, being it relationship to other people, being it the body itself. Okay, what happens to all these things that cannot adequately be quantified at all? Are there strategies to deal with it? And I would say no, there aren't. And finally, who pays for the economic cost? That's of course that are the companies, but who pays for the ecological costs of the trainings? And these costs are really heavy with regard to minerals that are scraped out of the earth in various parts of the world, and of course the energy it causes to drive all these calculations. Okay, a third point I have here, and this is the vector thing. Who controls? So these vectors, these numbers that you see there, represent the meaning of concepts and how they are interrelated to each other, millions and millions of them. Who controls the quantified meanings of this network? So who's in charge for making sure that it makes sense in a way and is not just some kind of outcome of brute force statistics? This is a question of fine-tuning, and this is expensive. Interestingly, in our work, we found indigenous artificial intelligence projects that discuss these vectorizations, these numbers, and the relations of these vectors with elders and knowledge keepers in order to make sure that the interconnections between the concepts are culturally graceful, make sense. But of course, this takes a lot of time. It's a tedious and slow process, and it's not a process for making quick money with AI. Okay, so much about this clip technology. So if we use such an AI system, if we put in a prompt in any of these systems, we activate this clip module first. Before anything other happens, we activate this clip module. And that means we use that and we rely upon that. This is what we have to kind of believe in that, a kind of practical belief in order to use that. we have to question this kind of belief, of course, at this point of time already. So we see it's a complicated relationship to using AI, be it in the arts or for scientific purposes or whatever. So the results of this is then passed on as a vector to the next module. And this is a module that has been trained with different data sets of even more images to let images appear from pure noise. So this is a trick that current text-to-image AI and text-to-video AI technologies use. So they have the images and then they blur these images with a Gaussian filter, so it gets more and more blurry. And the algorithm is trained to trace back from the blur to the clear picture. So this is the way it's trained. And if you then give such an algorithm just a random statistical noise, so it's just a noisy picture with nothing, no information in it, and you connect that to a word, to a concept that it has pre-trained in the clip, then it's possible to kind of identify the structures in the noise that relate to this kind of concept and then to denoise the image. So this is why it's called a diffusion technology, right? So it's a pre-trained diffusion and then it's a denoising technology. We are not to really talk about AI in human terms, but this is like if you look at a cloud, it's not like really, but it's similar to or analogous to if you look at a cloud and you see let's see some animals, you identify some animals in the cloud. The big difference is for us, it's a kind of gestalt, it's a kind of form that we live in that has a meaning for us. But here it's just statistics and quantitative relationships, right? So, okay, if we use an AI, this is what's happening, and this unit and scheduler actually do not read our prompt directly, but get the vector or similar several vectors from the clip network, by the way. And of course, here we have all the same questions again, all the same questions about where does this data set now come from, and all the questions that I just raised, right? So something I should mention with the clip, and I forgot to mention that, the first module, is that there are multilingual clip models, but they have a heavy bias on the Anglophone, on Anglophone semantics and grammar. So it's like at least 50% of all the words are in English there, and the other 50% or part of that, you have some like 25% or 24 names, which can be translated in English language. So, but the rest of that is and contains 100 languages, and these are of course not all languages on Earth by far not all languages, at least like you would have in probably Kenya or in Nigeria, where I know there were like 500 languages spoken. So it's a very, very tiny fraction of what humans had built up as their means to understand the world and to communicate, right? And the biggest part of that is in English, is Anglophone, and of course it inherited the logics of the English, the grammar logics of I do something and not differently. So the relationship to the world, the structure of the relationship that's embedded into the language is then inherited by this clip module, and steers all these processes. Cool. Okay, finally, the last part is the decoder. It's not that interesting to us. It retranslates the latent image into a human visible image. Interesting thing about that is everything that has happened until now has to be translated, back translated for humans. And that means humans cannot control or understand what's happening right before the decoder. All these are highly abstract kinds of imagery. They are kind of pixel images, but the pixels don't have a meaning. Don't have a meaning for us. It has a meaning as a combination of different statistical representations of numbers at this kind of point of pixel, and this gets then decoded so that we can see a clear image for us. So it's not really human controllable what's happening before that. So much about the logics of this kind of AI and the problems it comes with. Now let's see. I want to introduce 4 selected approaches towards AI and how they might inform our practices. The first one is an approach of what we could call radical hope. And this one is represented by a writer and a filmmaker. It's Charles Tondere Modede. So he's born in Zimbabwe, and kind of my generation. It's from 1969. And he gave a talk at a conference in Germany, and was an important conference. Unfortunately, he couldn't be there. This was called AI, Ancestral Immediacies at the Haus der Kulturen der Welt, the House of the Cultures of the World in Berlin. It's a wonderful facility there, which hosts important conferences. And he had the keynote on this conference. And this, of course, got my attention. And he gave a talk and he wrote, he basically boiled that down for an article in eFlux, in the eFlux magazine. And it's very interesting. So the approach of him, he refers to the massive knowledge that is included in AI. Virtually any text, any picture that's existing in the cloud, in the digital world, has been scraped off. So if you think about that like this, it's fascinating how all this kind of world knowledge is in the AI. And if I say all the kind of world knowledge, you should have some alarms ringing in your head, because of course it's not all the world knowledge. First of all, how much of this world knowledge is digitalized or could be digitalized in a good way? And secondly, on which parts on Earth had the money and the means to digitalize their culture, and which did not. So this is already wrong to say this, right? But there's a lot of things, of course, everything that's on the internet, everything that's been done there, and of course a lot of knowledge and books and history. And this is what Modede starts from. So he had the idea, well, if all this knowledge is inside these machines, they know about slavery. You could ask GPT-4 about slavery, one of the, of course, greatest tragedies and crimes of mankind. So he thinks, well, if this knowledge is there and we have this kind of intelligence, what could happen? So I read just the quotes here. So he asked, but what if a machine not only remembered those darkest of days of slavery, but also realized how they continue to structure the capitalist global economy of our times? So this is what it's about. One thing is history, but the other thing is how history is not history, but is present in how it distributes wealth, life chances, everything, until nowadays, economies and everything, hegemonialities, you name it. So he asks, what if with this technology, economics really became the splendid dream of the neoclassical school, not a matter of social history, but models and algebra? A political economic machine that really lives up to the Benthamite promise of generating the greatest amount of good for the greatest number of humans. What kind of machine would this be, he asks. Benthamian, there was this philosopher, British philosopher in the 18th, 19th century who coined, or is famous for, of course, the utilitarian approach, the greatest amount of good to the greatest number of humans. So it's radical enlightenment, if you want so. What kind of machine would that be that takes this into account and would be really abstract, really number focused, and then forget about all these cultural aspects, he asked. And last quote, if AI becomes not just us, as the computer architect Blaise Aguirre-Arcas maintains, but much more than us. If it sees society in technical rather than cultural or spiritual terms, then the days of slavery will not only be remembered but erased, cleared. So erased does not mean the memory is erased, but the consequences are erased. So you see, Modede calls this approach a radical technophilia. So this is a kind of utopian thinking about this kind of technology. If it would be a really benevolent technology, what could it do for us? Could it really erase all these horrors of history, so to say? And I think this kind of position goes back to a long way in the United States, at least several decades. And I always have George E. Lewis on my slides. He's a jazz musician, and he is member of the Association for the Advancement of Creative Musicians, and located in Chicago. It's a pioneer in free jazz and experimental music and computer-made music. And for George E. Lewis, he programmed this Voyager software for decades as a software that has certain aesthetic principles that stems from African musical aesthetics very much, but not only, also from Indonesian aesthetics and many other indigenous aesthetics. And for George E. Lewis, the generative software, it's not an AI in particular, because there wasn't one at that time in this form. But he programmed algorithms that are kind of autonomously reacting to music. Generative software, says, is an algorithmic, culturally sensitive dialogue partner and bears a decolonial liberation program. So that's my interpretation. Yeah. So he says about Voyager, it's aesthetic of variation and difference of the softwares is at variance, he says, with the information retrieval and control paradigm that late capitalism has found useful in framing its preferred approach to the encounter with computer technology. So this is about how we look on digital technology, and we, at least I can say that as socialized in Germany, it's so normal to look at this kind of digital technology in this way, in this capitalist framing way, that this is really an important information that Lewis gives us here in this article. He writes, as I've observed elsewhere, interactivity has gradually become a metonym for information retrieval rather than dialogue, posing the danger of commodifying and ultimately reifying the encounter with technology. And this what, of course, happened now. Meanwhile, commodifying, reifying technology. But there's another very interesting word here, and it's very important. It's dialogue. Dialogue with technology, and not let technology replace persons or let do things for you like a robot in this kind of slavery thinking, right? Yeah, just to give you a short glimpse into how this sounds. So this was radical hope. Now, second part is radical critique. And here I relate to Kate Crawford. She's a senior principal researcher with Microsoft Research, interestingly. And she's one of the really deep critics of AI technologies, co-founder of the AI Now Institute, and wrote this important book, Atlas of AI. It's a kind of misleading, I think, it's more geology of AI, Atlas of AI. This very really important book, and what she's pointing to is the dimensions of extractionalism that AI does. I talked a bit about that already, but let's have a look at this diagram of the book. So at the lower part we have the planetary matters. So we have the planetary exploitation, fossil energy, rare earth, toxic waste, cooling waters, and everything that's of course extractionalism. Every digital technology does that, but now it's multiplied because everyone needs AI, and we need much bigger server farms and everything. So secondly, exploitation of work. So the data click work, I mentioned that, neocolonial exploitation, but also the creative labor, and this kind of work, the data scraping that is done there. And so we have these layers of work, of culture, and then we have the layer of episteme. So this is called And she called this classification. So what AI does is this kind of categorization that I talked about, classification, commodification of traditional knowledge systems and intangible cultural heritage happens here. So it's taken away, so to say, it's dissected. In all these technologies I showed you with a clip and everything, it's just it's like a chemical solution, chemical dissection of all these entanglements of meanings in order to reassemble all these meanings and sell it back to you in a way, right? That's kind of ironical. They take this culture to dissect this, to make it a statistical entanglement, and then sell it back to you as something meaningful, which it mostly isn't really. In art, this kind of position has also a name, many names I would say, but I chose this one, Sherif Wong. She's an artist with a focus on AI governance, affiliate on many boards, and research scientist at the KIT lab of in Berkeley. And she's very much focused on AI governance and regulation of AI, and which is why her art is not really AI art in the sense I talk about later, but it's interesting. And just to tell you this interesting source here. So she made this artificial life coach website, and it's kind of ironically talking about AI in form of horoscopes, and you have all these different star signs there, and what you should believe about AI. It's really ironically made. And the important thing is the box there on the right, because it has very, very important sources for thinking critically about AI. Asking the question, what power source have we plugged into? So this is the critical stance. And now the third one is artistic autonomy. And I will now refer to Hito Steyerl. She's a professor at the University of the Arts in Berlin, and she's an internationally renowned artist and theory. Her works investigates the dynamics of digital image production in various forms for many, many years now, surveillance technologies and global power structures. And we will now listen to what she says about a work that she did, and this work is called Power Plants, and it has been given at the shown at the Serpentine Galleries in London.
Where we cannot, without you, without me.
The exhibition is called Power Plants, and essentially it's several works dealing with the park, the surrounding area of the Serpentine, and trying to see it both through the lens of plants and flowers, but then also through the level of the area's real existing economic inequality. So I guess that's the two levels the show operates on. And then there's also a series of video sculptures, which is called Power Plants, and which are actually AI predicted or generated flowers that an AI has calculated into the future. The question about AI is very simple. I think most people believe that whatever an AI comes up with is the truth, and I don't really see that this is the case, but I still want to know how it works and what kind of results you could actually achieve using it. So mainly it's about understanding it, but also about showing its limitations, right? Because if you actually look into the future using an AI, then you will see very quickly that this future is extremely blurry, right? And you won't be able to recognize anything. A snippet in the soundtrack of the show is actually being produced by an AI. I trained a neural network on my own voice repeating "this is the future" and asked the AI to predict that. So it keeps saying "this is the future" in my voice. I mean, this is extremely tautological, right? First of all, it's very strange kind of prediction it comes up with, and then all it has to say about the future is literally the words "this is the future," right?
Okay, what we saw here is something quite important. Firstly, Hito Steyer programmed her own artificial intelligence, as many artists did, and maybe do at this time her own from scratch. So this is a project that is in her authorship, in her ownership, not just something she took and used to generate something or so. The second thing is she explores how far can I get with that. So she has a critical distance in her work, because her work itself, the AI work itself, is focused on AI. So the form AI is focused on the content, question of the content. What is AI? How far does it get us? Does it help us? How is it attached to human affairs? And everything like this. So, and she sees that it's limited. So it's an artistic exploration and artistic research of the reach and the limitations of AI. And of course, you could say with newer technologies, you would have to try it again and again, whatever. So this was 2019, this exhibition, and of course, training of AI even earlier. Many of these artists did that from on 2015, 16, or some even earlier of that. Now let's hear the same Hito Steyer talking about stable diffusion, the technology I showed at the beginning with the clips thing and everything.
It's not the case with stable diffusion. We know the code, it's out in the open, so this is not a black box algorithm. What this actually is a white box algorithm, which means that I have been white boxed. It is a social filter, if you like. It is an approximate of how society, through a filter of averaged internet garbage, sees me. All it takes is to sort of remove the noise of reality from my photos and just extract the social signal instead, and this is what you get. But I'm not complaining, because actually I think it's fair enough. I have my own internal model of what stable diffusion actually looks like. So if you prompt me to tell you what does stable diffusion look like, it looks like this. This is the one and only true portrait of diffusion models, and I'm running this kind of revenge algorithm operation in my own head. So the question is, what happened on the way from these more traditional photographs to what I call statistical renderings? What happened? And I think that these statistical renderings shift the focus of representation from establishing fact to expressing probabilities. They are data visualizations that do not really require any longer sort of indexical reference that photographs used to have, but they basically render probabilities. And what they do is they represent the norm by signaling the mean, and they represent likenesses with likelinesses.
So you see, this is a fundamental critique of stable diffusion, and the core point here, I think, is the thinking about this. What does it mean to average something, to disembed that, to disentangle that from its origins, and to mix that up into probabilities that just come together as vectors, that means as kind of errors in space that have some kind of angle to, with relation to each other, which is more near or not, and this is the criterion if they belong together or not. So, and we could, of course, have a philosophical discourse on likeliness and likenesses. So the quantitative likeness and the qualitative likeness. One is connected to trying to follow the truth, and the other one is just to make a prediction that's probably happening in the future, which are different things. So fourth position. This is cultural autonomy. The third was artistic autonomy. The fourth is now cultural autonomy. And here we will hear another academic, another scholar. It's an indigenous scholar, Susan Kite. She's an artist, and she is a PhD at the from the, I guess, Institute of American Indian Arts in Canada, member of the Research Creation Network, connecting indigenous knowledge with performative technology and sound art and artificial intelligence. And this approach is one of the most important, I think, to my research nowadays. So let's listen to what she has to say.
So to me, our activities are focused around Lakota semiotics, which I'll talk a little bit more about, song-making practices, public communication through artworks, developing AI tools to collaborate with human dreamers, both sleep and waking, publishing about the application of indigenous research creation methodologies. So a lot of this stuff is focused on capacity building, on methodology building, on experimentation. And I hope that that shows our funders and our future funders and our community members that artwork is essential in the exploration and creation of new things. We have, in this grant, we are thankfully encouraged to have community anchors and community partners. And we also have the ability to collaborate extremely cross-disciplinarily. So AI developers, architects, neuroscientists, linguists, designers, knowledge keepers, working with EEG and cultural practices, cognitive science, all towards developing kind of more complex explorations of AI through Lakota knowledge. So to me, my questions remain, like, what is the connection between materials from the earth formed into sculpture and materials from our dreams, which are formed into song? How does Lakota philosophy see the human body in relation to the creation of new knowledge? So I want to build on this previous research on how Lakota ontologies prepare us for making new relationships and covenants with non-human beings, such as possibly AI. And to me, it's like an endless argument probably, that indigenous research creation methodologies prepare us to approach AI, not only from a material perspective, such as methods for listening with and through stones, but from the perspective of knowledge received by Lakota people through a hambla, through dreams or visions. Adopting Lakota-specific methodologies into our computational tools opens this possibility for developing Lakota AI. So hopefully we want to transcend notions of artificiality, and especially transcend notions of a Western intelligence, which I see as total myth. It's like there's no such thing as artificial in this world, and my community doesn't seem to prioritize intelligence as the marker of what makes someone worthy of caring for. So these methods assert that Lakota knowledge can be dreamt, made, interpreted, worn, all through the body, and always in connection with body, spirit, land, and cosmos.
Okay, what we see here is really a paradigm shift, at least for me, probably not for people that have grown up in Lakota cosmology and ontologies, because it's a whole completely different thinking about technology, the relation of technology, and how we are embedded in this kind of intelligence or knowledge spheres. And we see this was an example, not only an example, but a really important activity from Canada. Another important activity, in this case from Australia, is this indigenous startup. It's a profit for purpose startup founded by Michaela Jade, and we hope to win them as project partners. We already had a good session together with. What we learned in this first session already is, for example, that AI is a completely different scene. It's a part of the histories. And not only the human histories, but the human, non-human histories, the histories of the earth and the minerals. It has a meaning where it comes from. These things cannot be separated, they are for Western view. So it has a meaning, and to me this translates as there's a responsibility towards these minerals that we have, as they have a responsibility for us. For example, if they're in a computer that saves our lives in the hospital or whatever. This kind of relationship. AI is a curatorial medium, in this context, for intangible cultural heritage, curating languages that would get lost, stories, forms of expression, and they program the AIs as told. The ways of trainings are not typical for technical innovation cycles, but are a continuation of cultural practices of transmission and of care, the tagging and the vectorization of the elders. And these projects, most importantly, are always connected to educational projects and to social care. It's one project, actually, that does research on AI and does educational activities and does social work. So it's really it's really entangled, you could say, something that's quite unusual in the Western world to have. And I think it's very, very interesting to think about that and what this means and how it can work from here. So my conclusions: lessons unlearned, healthy approaches to AI, or let's better say less unhealthy approaches to AI. What do we have learned? So just a very quick systematization. So the attitude of radical hope that sees AI as a utopia, and the method is imaginary reframing, and it's related to cultural realities very much, but less aware of economic realities, I would say, critically. And then we have the radical critique, the dystopia. It's a cognitive reframing is the method to critically think about something, and sees economy as an active player and culture as an object or victim, rather, of extractionalism, which has to be saved. And then we had artistic autonomy and sees AI as a means of expression, and the method is artistic reframing. Art following its aesthetic rules only. It's only responsible for its own aesthetic rules in the first place, generates strength out of itself because of its symbolic nature. And this makes it possible to explore, but of course it's only symbolic, as this the paradoxy of art. And then we had cultural autonomy, where AI is seen as a curatorial actor, a means of care and a means of healing. And this is a cosmologic reframing, and it connects culture and economy, but both embedded in indigenous cosmology, not economy in the Western sense or so, but an embedded economy. And that leads to what I would call a deep redefinition and recontextualization of technology that's most interesting. So what do we learn from that? Learnings is, firstly, it's important to overcome limitations of established hegemonial viewpoints, and we need imaginary reframing for that. Secondly, it's important, the radical critique is important for deep structural understanding of AI and its context. And what I showed you at the beginning, I hope, it's kind of technical, technological, and most people don't like that. But this is how we understand what it is in itself. So we have to, for part, we don't have to study informatics or applied computer science, but we have to follow that route. So third is artistic autonomy. It's important for media aesthetic informed strategies, as we saw. Perceptual politics, how do we perceive the world and how does AI change this? And practice development also. And finally, the cultural autonomy calls for culturally rooted orientations for technological and political action. It introduces non-Western artistic approaches entangled with care and educational work. And I think this is showing, and also the conference schedule shows a lot of these directions where it's going. It's just a short glimpse at our AI for Arts Education project. And you have a QR code there if you want to know more, or just write me, where we ask the question, can a better AI be built that's not following economic premises, but artistic and educational ideas on? And if then, how can we build this kind of better AI? And this has a lot of implications. Thank you for listening.